Okay, the meeting is started, and now I can admit the people waiting in a lobby. So I am admitting them all.
Good morning. Good morning, everyone. Join us. I hope you all have a cup of warm coffee with you or tea so that you will enjoy this fantastic webinar that we have ready for you to enjoy today, this morning.
Yeah, thank you, Madam. Thank you for welcoming us.
Of course. My pleasure to be here this morning for this fantastic, amazing topic that we have on battery management systems. I think there is a lot of attention on that, obviously. So we will have very nice discussions and very, very nice presentations with an amazing panel. So a lot of people joining this meeting today. I see all the time coming in more and more people. So let's give some moments for everybody so they are settled to start this meeting today, this webinar workshop. Good morning, everybody. I think we can slowly start with this fantastic webinar, which is about battery management system, but the title of it is Securing Self-Supply, Navigating External Dependencies in European Battery Projects. My name is Maitane Berecibar. I'm a professor and head of the Battery Innovation Center at the VUB here in Brussels, and it is my pleasure to moderate today this webinar. Let's go a little bit through the agenda that it's full of interesting discussions today. First, we will have, of course, introduction of the different speakers, amazing panel that we have today, get ready. Then we have the presentations of each of the speakers as well, giving us the understanding from their side on this topic and on their work that they are doing. Afterwards, we will start a panel discussion, and then we will go to the Q&A session. So there, in that moment, you are free to ask any question. Please place it in the chat. You can place it at any moment. However, we will not stop at each of the presentations and do some Q&A there after each of the presentations. We will have the moment to discuss all the questions that you may have at any point of the meeting in the Q&A session. And then finally, of course, some highlights of what we have been discussing on this amazing topic and closing remarks. It's time to say, of course, what is this alliance? What is the Battery Management System Alliance? So today, this BMS Alliance is a compound of the different projects in which they are working on this. We have Energetic, BATMAX, NEMO, and next BMS projects. And actually, they are aiming to develop and implementing the next generation battery management system technologies. For what? For enhancing the battery performance, the safety, the adaptability across, of course, different kind of applications. Batteries are needed everywhere more and more. And the main results at the end are the system design with development of the adapted models, but also sensors that we use more and more on batteries. Automatic model updates based on, of course, this improved sensor data as well. Efficient parameterization framework for physics-based models through the full entire cell lifetime. And at the end, we are, of course, creating advanced battery management systems that need to be updated all the time with these new actions that we are doing every day. This is the aim of the BMS Alliance, as you can see. But of course, let's start with this very nice panel that we have today. You have here the names of each of them and in the projects that they are working. We have Hoang Anh-Tai. He's coming from the project Energetic. and he's the Public Affairs Officer at Forsee Power. Thank you very much for joining today. We have Noshin Omar. He's the chairman and founder of Avesta Holding. He's coming from the project Batmax. Thank you very much for joining as well today. We have Sazzad Hosen. He is working in NEMO project, and he's a research professor and senior researcher at VUB. And as well, of course, we have Markus Berger coming from the project Next BMS. He's a senior project manager at Bosch. Thank you very much for joining the webinar today and for providing the very nice presentations that you will do right now. Thank you very much. So now I think it is my pleasure to start with the different presentations that we have. And actually, it is my pleasure to give the word and to give the floor to Sazzad Hosen, that he will present the NEMO project and the activities that they are doing on this exciting topic. Welcome, Sazzad. Good morning. The floor is yours.
Good morning. Thank you, Maitane, for the nice introduction. I'm again Sazzad Hosen, working as a senior battery researcher in the MOBI research group from VUB. I'm coordinating the NEMO project, from which I will speak about the project itself and also maybe from the battery research bottlenecks from a research project perspective from academia. But maybe before going that, let's have a look what we are doing in the NEMO project. And this is a project which started in May 2023, will run until next year. In this project, we have partners mostly from the Central of Europe and varieties of industries, but no battery manufacturer. This is something to note. What we are doing in the NEMO project is focusing more on the electrochemical impedance spectroscopy. For this, we are using the Infineon EIS board with the Infineon chip. Using the IAV BMS, we are developing different physics-based and data-driven models, which you see in the right side, and on the left side is the hardware. At this stage in the NEMO project, we have now already built our NEMO module. What you can see on the right side, we call it ZBMS module, and this is now under test to validate our project objectives. Now, looking into the core topic of today's research. So as I said, that we didn't have any battery manufacturer on board, but we needed a lot of battery cells, mostly commercial batteries for our project. We needed around 200 commercial battery cells. So we had to look into the aftermarket, and this is where we faced a lot of challenges. And this is also my experience from previous projects, that this is always a challenge to find battery suppliers, especially the commercial battery suppliers, especially when you do not have a battery manufacturer in your project consortium. The factors that I always found that very key to find a battery supplier is going on the right side of the picture, the availability of the cells. And probably you focus more into the high nickel generation or any specific chemistry that you do not find in the aftermarket. So this is a challenge if you have a very specific focus in your project to find the right battery cell. The lead time is also another challenge because the batteries are not always ready. So once you order and then once you receive the cells, had to be in line with your project timeline, which is another challenge. It is usually less of a headache because the budget should always be inside the project allocation. But in the reality, when you start looking into the cells, the amount of money that you need to spend may not be the same what you have available. Suitability is referring to the chemistry and the size and shape, especially if you have a very designed KPIs and you need to build a battery system. The selection of the size, shape are also an important factor. And then in the end, confidentiality. This is another challenge with the battery manufacturer, that whatever you find, not always agree on your type of investigation, especially if you focus on the electrochemistry, you need parameters taken out after postmortem activities of your battery cells. The manufacturers are not always very prone to agree on these terms. Now going back to the list on the left, so what we faced a challenge that was to find an European battery manufacturer which fit to our purpose. Unfortunately, we had to look into the non-European suppliers. The positive side on those cases was that we had different choices, that what type of cell, what is the nominal energy, that nominal capacity that we are looking for, and we had varieties of options to choose. Accordingly, we had also budget options and that we could choose from. The communication was also quite faster, straightforward. We could choose the battery cells pretty efficiently, and then the shipment was also not a big problem to receive. So we could receive all the battery cells that we need just on time and in line of the project, which allow us to do our research efficiently. And on the NDA terms, we also didn't have to go through a very detailed NDA process to work on it, and we could do our investigation as we have planned in our project. Everything fit NEMO well. So that's one of the reason that we looked into the non-European battery manufacturers. But from my experience, it's also similar from previous projects as well. Now, what is the status at the moment on the global battery share? Probably the next speaker will explain these more in detail. But what I see in a draft picture that almost 90% of the battery manufacturing these days are coming from Asian manufacturers. EU is trying to catch up, but what are the types of funding available? Again, my next colleague will explain more, but what I see is that innovation funds, this year they have funded 6 projects, which is worth of 850 million, only for the industries. But as side by side, we also have a lot of European open calls that the research and development and research and innovation activities, the battery manufacturers could participate. From my experience, what I see that European battery manufacturers are mostly focusing on industrial scaling, and also they are a bit sensitive to their own IPs. I quickly looked into the database that the European Commission already have and tried to look into the picture that how the European manufacturers, mostly not everyone is included in this list, but the ones, the major partners, including the associated country manufacturers. I see that in the last 10 years of Horizon 2020 and Horizon Europe, there were 142 projects. Again, the numbers may go plus minus. It's 142 projects where they participated as a partner. This is assuming that they provided the battery cells to those projects, but maybe they also are in combination of more than 2 manufacturers in one project. Just an indication to have a look that where we are lacking in the research projects arena. I also checked the project database that from Horizon Europe and Horizon 2020, selecting the right categories of transport, energy, and climate change. And with the battery keyword, I could find 415 projects, which is 3 times more or less higher than the number of projects where the battery manufacturers were involved. This is not, let's say, a 100% accurate amount, but this gives you an indication that there are a lot of projects, more than twice, that these projects require battery cells, battery materials, which they need to procure from aftermarket. And I give you already an example in the NEMO project that we had to look into non-European suppliers. So there is market potential for EU suppliers to take part, not only as terms of projects, but also in terms of as an external supplier to the projects which are approved and require battery cells for their investigation. So what could we do in future to minimize this gap of the battery need versus the battery supply? That's just a recommendation from the project side and also from our side, that we could give a more encouragement to the EU manufacturers. Especially there are now FP10 coming up with the European Competitiveness Fund and maybe more projects in the pipeline. The Innovation Fund and all other pilot funds can continue, of course, but they could also have the research and innovation action projects participation KPIs. And this way they could be also, I would not say forced, but more encouraged to participate as an external supplier to a project. IP protection is an issue from an industrial side that I have also experienced while talking to different European manufacturers. This can be a bit of protective from both sides on sensitive outcomes, especially the research projects which are designed to be open and the data should be published as an open source. And then together and as an industrial development, we can co-develop the different battery technologies, not only the current generation, but also future generation with the different innovation actions. And on this case, we need more effort from both sides. With this, I would like to thank you again for listening and joining the webinar. And I will pass the mic back to Maitane. Thank you.
Thank you very much, Sazzad, for this very nice overview. I take this highlight of more encouragement to European battery manufacturers. This is, I think, a good point to highlight today. And who else better than continuing with Noshin Omar in this discussion with his presentation. He's the chairman and founder of Avesta Holding, and his presentation is about battery production in EU, which are the challenges and opportunities that we have today. So it's very nice to have today Noshin as a speaker so that he can give us a little bit of more insights on this topic for sure. Thank you very much, Noshin. Welcome. Good morning, and the floor is yours.
Good morning. Thank you very much, Professor Maitana. Can you see the screen?
Yes, perfectly. Thanks.
Good.
Noshin.
Perfect. So I'm partially representing the BMS project, and thanks for the invitation and the lovely introduction by Professor Sazzad. But I want to tackle this presentation from another angle. European battery cell production, is it a reality or a dream, which is coming often the last years. If we look to the market now, the lithium-ion battery market is quite largely dominated still by the Asians. I will say Asians because in the beginning it was Japan and Korea, and then it shifted afterwards more to China. We have been trying to catching that up, as you can see here, but unfortunately the entire process has been slowed down for many reasons, which you will see afterwards. But still, even the market is little now in slowing down when it compared to e-mobility and electrification. Still, the market will catch up in one or another way by 2030 and beyond. If we look to that translation to applications, still the mobility, the big part. However, based on the last figures, we see that the stationary storage is becoming more and more important due to geopolitical situation in the world, disconnection from the Russian grid, being energy efficient and so on. We see the green part is just becoming bigger and bigger, and the consumer electronic, it was each time in a stable industry. Now, if we do zoom further on those, what has been tackled the last years in Europe, this was a map, lovely map of European gigafactories. If we now compare that with the new reality, actually 90% of those players doesn't exist anymore. Either they have been stopped with their project, either they went in a bankruptcy, either they could not get it into financing. But what is remarkable in all those projects that you see, over 90% of all those players, they were focusing on the NMC technology. So simply copy pasting each other without any reasons why they are doing that, because their main focus was just the automotive industry. Now, if we look to the different generations of the batteries, we have the commercials, what we call it generation 1 or 2 and 2. We have the advanced generation 3, which is on the market or close to the market, and the solid-state technology with all the characteristics, as you can see here on the left side. What does it mean? The entire industry that we are dealing here and here should be dealing in one or another way with all those technologies, because the application, stationary, automotive, they have different types of characteristics, and there is no one technology which can serve everything. That's a hard reality as we are dealing right now in the conventional market. We have gasoline, we have a diesel, and we have another fuel types as well. So if we look deeper in the Volkswagen roadmap, it's actually representing the nice case that we have different types of vehicle segmentations, and those vehicle segmentations, they will also need different types of battery technology. So it will not just be NMC, which will be the winning one. Also, lithium iron phosphate, LFP family, I will say it, will get more important. It's showing that's already covering more than 60% of the market. And for some specific segmentations, we will also need the solid state, but the entry market of that will be much more for luxury and hyper class vehicles. Then you will see actually that those LFP technology will take here much more places over, because this technology is also in continuous development and improvements. Those technology will not happen in one step. It's a huge development behind that. It is working on everything: the electrodes, the cathode, the anode, the electrolytes, the cell design, the interfaces that should be optimized, the scalability of the technology should be done, and those will lead continuously to improvement of the volumetric and the gravimetric energy density technologies. Now, if we look to specifically to this technology as such, which will be mainly in the future based on lithium metal technology, unfortunately, this isn't even a technology, lithium metal, which is not existing all in European scale, not from manufacturing, but even not from the requested scale that we are looking to that. And that isn't something which we have to take care about that as an attention point for the next programs. Now, what happened when Chinese EVs players start moving to Europe, like BYD and others, NEO, and they start coming with their LFP technology, 20-30% much cheaper than NMC. European industry become actually in a big troubles, and that's why the shift from a lot of European players, automotive, also moving, they start moving to the LFP technology, and the LFP become much more a dominant player as a chancery in Europe as well. But unfortunately, if we go back to this picture, there were no LFP factories in Europe so far. So, and that is where the first collapsing mechanisms in the European battery industry happened. Last slide, why we failed to such extent, not completely, but to such extent. We never expected that the price evolution will be so significant between LFP and NMC. And the improvement of LFP will be so significant, and even sodium is now making that. When we start shifting from NMC to LFP, the lack of IP was in one of the biggest problems that we ever had and faced in European level. Upscaling challenges that we have been neglecting that from a while, still we are neglecting, and I think a lot of gigafactories are still making the same mistakes. They can still believe and dream they can go from grams to tons in one day. Complex battery supply chain, which we don't have it yet in Europe, so that's not reality. Long delivery time of production lines, or changings or modifications of them. Changes in business and financial models. One key element there was the increase of the energy pricing, which has huge impact on your financial models and collapsing. And last but not least, but the harder reality is that there's still a lot of gigafactories that have been built. They never had actually real customers behind that. So they have started building gigafactories and with the hope of being customers. And that were all combinations why we got such type of delay. So the message from my side for the next programs is that we should be much more realistic in our roadmap. We should not exclude any technologies. We should be quite very open to all the technologies, and we should give much more attention to LFP technology, and we should not consider as a Chinese technology. LFP has been developed in America, in Europe in the beginning, and then afterwards has been transferred to China. But we have to look to keep our roadmap completely open and not to be for 99% focused on NMC and to neglect the rest, where afterwards we will be starting blaming ourselves. And that is a short summary from my side regarding this specific topic. And again, apologies for my such maybe harsh messages, but that are the conclusions which are coming from the market and that we are facing in this industry. Thank you very much for your attention.
Thank you very much, Noshin. Thank you for this overview, for this understanding of the roadmap of what's happening today with the European battery manufacturer landscape. And with this, I'm sure everybody has many questions, but as I said, this is a kind reminder, questions are coming at the end. And now it is my pleasure to introduce the next speaker, who is Anh-Tai. He's coming from the energetic project, and Hoang is a public affairs officer at Forsee Power. His presentation has the title of European Battery Ambitions Require Resilient Supply Strategies and Strong Global Partnerships. So Hoang, we can see now your presentation in full mode. Maybe that was one of your highlights from the presentation, but now please give us your presentation. Thank you very much. Welcome and good morning to you as well.
Thank you very much. Good morning, everyone, and thank you for the opportunity to contribute to this discussion. So, yes, my name is Anh-Tai Hoang. So let me start just for a quick present introduction. So I am Public Affairs Officer at Forsee Power. Just a few words. We are a French company specialized in the design and manufacturing of smart battery systems for both electromobility and stationary applications. So we operate internationally with a strong industrial presence in Europe and Asia. Always with the ambition of developing safe, high performance and sustainable battery systems. I'm also glad to briefly mention the energetic project and to say hello to my colleagues if they are here for this webinar. Which is a Horizon Europe initiative in which we are involved and in which we are developing innovative solutions for the BMS, including AI and machine learning. So basically what I want to highlight today is the importance of looking beyond the cell for Europe to be sovereign in the battery industry. So the battery cell is often seen as the heart of the battery. That is, of course, right. But sovereignty in batteries cannot be achieved by focusing only on cells. So Europe's ambitions to become sovereign in batteries and to meet rapidly growing needs for the mobility and stationary storage. To achieve this, we need to take into account the entire value chain from the upstream raw materials all the way to the downstream recycling and second life application. So here in my screen, you have just one part of the battery value chain. And if we take the example of an NMC battery, you can see that the value chain starts long before the cell itself. So it goes back to the mining activities. as you can see from the extraction of copper, nickel, manganese, lithium, for example. And already at this stage, sovereignty over cells depend on securing access to the right components. Here, Europe has some strategic players, as Eramet, for example, or Imeris, working on highly important mining and extracting projects in France or in the UK, for example. Then you have the conversion and raffinage part, refining. Sorry, the step is largely dominated today by Asia, but is absolutely essential within the chain. As we get closer to the battery itself, we can see we find all the intermediate components, such as the cathode active material, so the CAM, and the precursor, so the PCAM, also the electrolyte. Each of these components play a key role in determining battery performance, safety, and cost. And it is only once we have secured these components that we can actually manufacture the cell. Then after that, just my point is that if we want to secure the cell supply in Europe, we must deeply understand how the upstream value chain is orchestrated. And today, most of the gigafactories are sourcing the components and raw materials from abroad. Our refining capacity in Europe remains extremely limited, while demand is growing at an expansional pace. Asia, by contrast, is in a position of oversupply. Once we arrive at the cell itself, so here, it is clear that it's a critical step in the chain, but again, it is just one of the link of a much larger system. After the cell are produced, we come to the assembly stage where there is the battery in red, which is precisely where Forsee power is active. And so then there is the integration in the vehicles or the industrial usage as a stationary, for example. So there are some segments of the battery that are interlinked. So basically, once we have the second life and the recycling of the battery, we can go back to the use of some elements of the battery materials. So this is why it's a value chain that we can put it to a circle, and that is very interesting to study. So Europe has we can ask if Europe has some resilience. So we can see here in this slide some figures from TAC. So you maybe know. So they published a study 2 years ago about this, about our about the demand and also our capacity, and I just picked two components of the battery, so the CAM and the PCAM. We can see that the demand is, of course, much higher than the European capacity. Normally for CAM and PCAM, from 2023 and today, there is no change, contrary to the cell demand and the cell capacity. So we can, if we do not provide the elements for the development of a battery, the cell is just an element, and so we cannot be sovereign in that part. Europe has very promising projects in the whole battery area, and I would like to highlight some from the French perspective, of course. Initiative led by some actors for example, like Orano and Axence in the north of France, which are focusing on the battery recycling. So in the left of the slide, they are truly strategic projects. And some others that were left over because there are some industrial operations that were expected, notably in the recycling part, but those did not succeed, even if they are secured funding from the Innovation Fund. They show how difficult it is to bring such strategic industrial project to operational maturity. So here you have, for example, the example of Eramet in Suez that just aborted the project last year. So just there are many challenges. Sorry for this slide. It's very there's too much word in this slide, but there are many challenges in order to be sovereign in the battery industry and just to secure the supply of cells actually. So there is the raw material challenge, the limited upstream and midstream capacity, the investment and financing constraint, the regulatory complexity, the competitive pressure from Asia and also North America from the Inflation Reduction Act, even if today might change a little bit for the US, skilled workforce shortage, circularity and recycling that is very important, and also energy cost and sustainability, as gigafactories are very energy consuming. So basically my conclusion is very simple. The entire battery value chain, including but not limited to cell production, is strategic for Europe. To achieve sovereignty, we must strengthen all links in this chain from extraction to recycling. Yet the reality is that the European value chain is still fragile and not fully mature. That is the real challenge we are facing today, and the one we are urgently need to address. So there are some open questions that I wanted to highlight. So how can demand side policies be aligned with supply chain development goals for maximum impact? Then what policies and investment are needed to accelerate local production capacities for precursor, CAM, and cell manufacturing? What regulatory adaptation are necessary to balance industrial competitiveness with environmental and social standards? And then how can cross-border collaboration in Europe can be improved to strengthen supply chain resilience against geopolitical and market shocks? So thank you very much for your attention and again for this opportunity to contribute to this very interesting discussion.
Thank you very much, Hoang, for this open overview and understanding that we need to consider all steps of the value chain, including also questions like recycling, Second Life, you were mentioning as well, adding some extras to these needs. Now we will continue with our last speaker, that is Markus Berger, and he is coming from Bosch. He's senior project manager there, and he's working in Next BMS. Markus, good morning. I see the presentation already. Thank you very much for joining.
Unmuted.
And
Thank
now,
you, Maitan, for
the floor is yours.
Thank you for the introduction, Maitan. Yeah. So yeah, thanks also for the invitation and for presenting an aspect of the Next BMS project. And the title is In Search of the Elusive Cell, and it will be a story about the project, how we executed, how we had challenges in the project. So nothing about global politics and supply chains, but of course we had to deal with the situation. And elusive in this context means it's a cell which is hard to obtain, which is not easily accessible, and where it really took some strategy and effort to get the right cell for the next BMS project. For the start, what is next BMS actually? So next BMS, it's one of these projects here, and the title already says we're looking for the next battery management system, enhancing lifetime, improving performance, or being fit for the next generation of sensors and functions. And you can see there is a workbench, I think at one of our university partners, and you can see it's about hardware, but it's also about having some demonstrator. And you see here, we need a cell for this. So I think also what Sazzad started at the beginning, I was shortly thinking you were presenting the same as I will present for our project, but the story will be different. So how do we get the right cell to do this research, development, to try our electrochemical models, but also to build a demonstrator? So also we have the plan to build a small module to really demonstrate the development that people can see, experiences, believe, and also we trust in our results. And this is a situation, and then it's a question, same as Sazzad mentioned, hey, which cell should we use? Maybe this comes first. Which cell should we use? And then comes, oh, where do we get it from? And I mean, if you have a project and you wrote all these proposals and made an agenda for and the scope for the project, there are already many constraints there, many requirements, and just to mention the top of them, So of course we want to do something of relevance, something of relevance for the next generation of battery management systems, for the next better generation of electric vehicles. So we were looking into high performance cell chemistry. So we were wanting for NCM, so not the LFP case. We wanted an NCM, nickel-rich NCM, really high performance chemistry, and we wanted that what we do is really relevant for mobility. So this is also the cell that we use should be in the portfolio, should be used in the vehicles, or vehicle the next generation. That were the key points. And then the more practical, I mean, Sazzad told it 200 cells. I think also we purchased some 100 cells. Of course, we want to have reliable results, so they should have some maturity, that it's not kind of the cell spread, production spread, which makes us or guides our assumptions. So we want reproducible results, high quality cells, series qualities, the cells, I told we want to make models. We want to execute simulation models, electrochemical simulation models. We want to build a module, and also we want to analyze what are the effects in the cell. So again, we need something which we can open where not so many restrictions on it. So it would be a problem if there's a cell with an NDA which says you're not allowed to open, you're not allowed to publish results. And last, it must fit in our budget plan to some extent, to some point. And this was really strict. I mean, we were planning aging tests, and all of you know, if you have these automotive cells, to do some aging tests, that is also a cost factor. And this limited, we have a partner, TNO in Netherlands, who did the testing and does the testing. But of course, they have a specific type of resources. So they reserved testers which just fit to a specific range of cell. So this is also an aspect. So we need to be fitting to the partners, to our economies. And of course, there are much more points. And well, I'm a project manager. How do you start this? You make a matrix. And this is an original matrix from the kickoff meeting. And you can see, I mean, you can't read it because it's my handwriting, but you can see we put all the constraints here on the left, and then we say, oh, what is the high-level options, and then balanced, okay, what do we care about? What does it mean? And to make it easy for you, I mean, this is the more or less the translation, or the easy to read version of it. So what we cared about, it was, of course, cell chemistry I mentioned. It should be relevant, should be high quality, no restrictions. We can do whatever we want, or at least we can do what we want with it. It should fit to our test equipment, And we thought about this would be some 30 ampere hour cell that would be perfectly fit to the equipment. It should be not too hard for us to build a module. Sazzad showed their module, so we're also thinking of something similar. We should be allowed to disassemble and also have the capability to disassemble. Simulation was also a topic. Do the models that we have at the beginning, do they somehow fit to it, from the chemistry, but also from the geometry? How is the cell reacting to electrochemical impedance spectroscopy and availability? Can we get the cell? And well, we made a relative rating for this, and I don't want to go too deep into detail. We can discuss it later if you have an inspect, but high level, if you have prismatic cells, pouch cells, cylindrical cells. I mean, the pouch cell is, I would say, almost a niche, so we didn't think this is good for us. And also the cylindrical cells, we thought, this is, I mean, it's used in automotive, but it's not what we consider as a mainstream. So we're focusing on a few points which were important to us, and this was, hey, this should be an automotive style type cell, ideally also used there. And the biggest challenges we saw here, hey, do we get this cell? And if we get it, can we do whatever we want with it? So they were the key points, and that's a nice thing. You can solve this at the beginning. Either get it or you don't get it, and the other one were our expectation that we don't get a problem there. So then you're at the point, okay, we know what we want, and prismatic cell, NCM, this size and stuff. Where do we get it from? Where can we source it? And the easiest thing is, there should be a partner in the project who can do this, and who has some prime access, or maybe who does it on his own. We had this before, a cell manufacturer, awesome, and he provides the cell. He's also interested. He's part in it, and that would be the ideal case to some. Even, I mean, we would need a European one for European funding. So the problem in our case, I mean, we had no cell manufacturer. We have a big energy provider. We have an OEM, Tofaş, from Turkey. We have several tier ones like Bosch, also AVL and others are there. They have sensor suppliers, we have research, but nobody who has really these prime access to cells. So this is kind of, okay, we could go to a cell supplier, but I mean, we have a tiny project and we want to publish your results and we want to analyze deeply your cell. So we didn't convince anybody, and there was no kind of such solid relation that we would get something. So cell supplier, not the manufacturer. So the people who use it, OEMs, I mentioned Tofaş. But Tofaş is they're linked to Stellantis, so they should have some access. But also there, we didn't motivate an OEM to share some single cells with us to do the research. What else? Contract manufacturer. So some company that can build cells on demand, so build to spec. Maybe some of these cell manufacturers that we saw before would for me also fall into this. They have no large series production, but they are capable to do this. And there were also some quite promising contracts there. So we could have built our perfect cell that we want. Maybe it's not used in automotive because it was just built for us. But then there's again this problem with the cost. You get a small series cell to a really high price per cell, or so on. Maybe not the best solution. And the last solution, the last option that we thought about is, gets to a cell distributor. So somebody whose business is to source cells and distribute it to somebody else. His core is to build this relation to the cell supplier to get the cells. And well, some years ago, I didn't think this is possible, but there's really something. And you can imagine, I mean, this is internet, and most companies are from China. There are two examples, just as exemplary. You can see that one. This is exactly the format. I don't know why they're all blue, but they are blue. You can pay with PayPal. It's from Calp. It's some NCM, or you can go to Alibaba, get the cell. They look all nice, and from name tag, they're fine. The challenge with this supply is you're not so super sure about what you get. Yeah, I mean, it's internet something. I mean, this recommended shop, and still you can see it here. I mean, this is almost all. I'm not sure if you can read it. This is almost all the information you get about the cell. And this is it's NCM. This is the size, voltage limits, current rates, something. Yeah. So this is not what we want. Yeah. So. Or not all what we want, of course, we want to know more, and we want to maybe discuss with the manufacturer, hey, what's this? How does it work? What do you know about it? So, but this is not possible. You can just buy there. You get, I mean, if you use PayPal, you not even get an invoice. Yeah. So the choice is limited. There's really scarce information about the cell, and I mean, I guess you know, or we have to admit, I mean, this is not the latest, greatest battery cells generation. This is, I don't know if it's leftovers or it's the previous generation, but this is a cell that we could easily get, and we could, I mean, you can get a huge a lot of this. We were taking care that we all have from the same manufacturing batch. But I mean, these cell distributors, they don't care what you do with the cell, so we're totally free what we do. And we didn't buy here at one of these shops. We bought somewhere else. But this is how the cell look like. So we put there some terminals to make the testing. And if we look now on the compromise or the result that we achieved, you can see here, this was our expectation, what we thought, which is good. And this is what we get. And if we kind of put the same standards, I mean, we don't have the silicon inside, so it's a graphite cell. And I mean, it's not the latest thing, so yeah, it's used for the mobility. The format is nice. Yeah, energy density is a bit lower. Fast charging is not the latest stated. Yeah, but the main challenge that we had, the restrictions and also the availability, we just replaced it by online shopping and do whatever you want. So this turned out for us to be a really good compromise. So it did not limit us in any of the high-level targets that we had or have for the next BMS so far. But at the end, we need to say, so it's the balance between the constraints. We have really high ambitions. We have clear expectations. But on the other side, our consortium has not this privileged access to cells, because we don't have the partners who have their own cells to bring it into the project. So if we can't convince somebody, we are limited to these public offers. And for us, it turned out to be okay. For the future, I would think, hey, if a project is drafted, if the consortia forms, if you're not able to bring some partner in who says, I bring the cells and they are really great and we build the project around these cells, ideally we should every project identify really quickly and early the target cell and of course secure the supply in order to not get into trouble. I mean, it could also happen that the cells you get don't fit your whatever aspect you have, so that you might be limited and need to change the scope of your project because it doesn't work. So for us, it worked out, and this is my closing slide. This is the real cells that we got there here in the electrochemical and the aging testing in one of our labs. And for us, it works good. If you want to know more about next BMS, of course, you're welcome to visit our page, our website, but also in this Battery Alliance webinar, there was an earlier occasion where Hans-Jörg introduced also this date and the scope of the project. Thank you for listening.
Thank you very much, Markus, for this overview and highlighting issues that we encounter when working on this topic on batteries. Where do we get the cells from? So thanks for highlighting this. I'm taking this to start the panel discussion now. So I would like to invite all the speakers to this part of the panel discussion that we continue now. Thank you very much for keeping the time. We are perfectly on time now. And actually, I would like to place a first question to you first, Marcus, related to this. And the question is actually, which are, from your point of view, the bottlenecks for EU manufacturers to participate in innovation action projects or research and innovation action funded projects for like we have now and you have been presenting from your point of view, Marcus?
Yeah, it's a good question. I mean, there are several companies. We saw this in other talks. There are several companies that are there. We know from the media that many struggle also about money. So funding is necessary. I mean, there should be people. The problem is probably they don't have the market access. They don't have the customers. So if you don't have a customer, you struggle to develop. You struggle to commit into investing money. If I think about my own company, I mean, we tried it in the past. I mean, if there would be customers, OEMs who say, "Oh, I purchase 2 million cells from you every year," so there would be some security in the business. Today, Asia is ahead. They're dominating the supply chain, so there's a high risk for these. And then it's small business where they try to. I mean, we saw they are also part there, but it's not the big thing. So I guess they need some security in making relevant business afterwards, and also learning from the business is super important, which is today, I mean, only the big manufacturers who are in series today, they learn so much from how their cells perform, how their cells are used. So this is a burden which becomes bigger and bigger as long as we wait.
Thank you, Marcus. Also, Noshin tackled this point, and I wanted to ask him as well, what are, from your perspective, Noshin, the bottlenecks of the European manufacturers to participate more in European granted projects?
From my point of view, there are 2 points which are becoming barriers for them to participate. Typically, the request for European project is for having the access to the state-of-the-art battery cells, something beyond what is standards, which means that should be still in development or should be further in development. To give an example, like solid-state technologies and battery cells with high energy densities, etc. So there is an IP issue, and also the deep investigation sometimes goes in European project. Post-mortem and so on. It's really a problematic. By the way, even in China, you cannot have access to such type of technologies. That's to be very clear. All solid-state technology that we are seeing from China, which is sold as a solid-state, that are actually semi or even quartz solid-state. Let's to be very clear there as well. And the second point is some of them are not reaching the level of providing such type of technologies. And that is still of them, they are still in the development phase or in scaling of the technology, and making the commitment to their ready is not easy. And then there is last point, which should also be mentioned. The European project landscape for a lot of cell manufacturing in Europe is very administrative process. So this administrative hurdle for them is really tough, and they prefer to focus on their core business. And I have really and I want to make a call to European Commission. If you want to make the life of European battery cell manufacturer in Europe easy, the administration should be really soft. And we, even as a company right now, if we get a request for European project, we will think 10 times about that, because our periodic report, which takes 1 year for review, then the conclusions are very well in a fast way made. So that is a hard reality that we are facing, all of us in Europe. So we have to be pragmatic. We have to make it much easier. leaner, but that way it will be very difficult actually to convince any cell manufacturer to step in.
Yeah, also practical highlights that we are hearing, of course. Hoang, what's your point of view here with the bottlenecks of the European manufacturers to step in a consortium for a possible successful project running?
From my point of view, as we are a battery manufacturer, so we talk a lot with cell manufacturers. I feel like they have already some difficulties to get to the industrial production, and the R&D teams are already very busy, let's say, for that, and it's very difficult for them to have the resources to participate to a European project. It's a lot of so it's very competitive. There's a lot of administrative work also, and also in some countries there are some funding solutions, national funding solutions, in which they are already involved, so they cannot extend their R&D team. I think the real challenge right now is the ramp up to get to the industrial production right now, since they are already decided which technology they are developing. From my point of view, when I see some gigafactories, right now it's the production that is the priority.
Thank you, Hoang. And I would like to also ask this question from another perspective, from academia perspective, also working on preparation of European projects. So, Sazzad, what do you think from your point of view? Which are these bottlenecks? How can you convince a European battery manufacturer to join your idea, your proposal?
From my side, I think most of the topics are already covered by Noshin. When I have reached out to European manufacturers, I have received the same answers. But on top of that, I would say that the number of European manufacturers are still low. I mean, as an options, we need more companies to come up with more various and diverse focus. In that case, probably with a new type of funding, industrial scaling up, we will have more opportunities to reach out to more players who are more willing to participate in European projects and then develop batteries together.
And then, of course, connected to this, then are we competitive enough? Is the European roadmap competitive enough from your point of view? I continue with you, Sazzad, if you don't mind.
In that case, probably I do not have the whole picture of a lot of industrial investments and the funding types here. But what I see that I mean, in Europe, we are, let's say, taking the Asian players who are also quite well advanced as a competitor. Maybe we need to look into the other way, that how can we jointly develop and go pace by pace. We both need to create an environment that we need each other, not like we are competing each other and then falling behind or trying to catch up what they achieve fast. This is something that we need to look at from European side. There are innovation funds and our competitiveness funding are also bringing in different ideas, different ways of improving the involvements. But here that would be my recommendation to go hand by hand and then develop projects together.
Thank you, Sazzad. Maybe we can go to Marcus with the same question. Are we competitive enough, Marcus? What do you think from your point of view?
Obviously, at the moment, not. Yeah? So we don't own the supply chain in Germany. or in Europe. Yeah. We talked about LFP. I think I saw somewhere LFP is kind of 100% in China. So obviously not. Yeah. But what's needed, and there I'm maybe German biased. Yeah, we talk about this technology openness. I heard this also today in a positive flavor. Yeah, so we need to be technology open for the chemistries. Unfortunately, the EU struggles also to have a clear and pertaining plan for e-mobility. Yeah? So we're still discussing how e-mobility should scale. Yeah? So this doesn't give the right framework. Yeah? So I wonder if politics or funding strategies can really influence the big business, big technologies, but for sure they can make the right framework to give some. I mean, the world is complicated enough, but to give some security for the own roadmap, what to develop, where to be, and not with every political change or every election, there might be a change in the political agenda. Yeah? So
Yes.
this is my thought about what the politics and should do and can do, give a stable environment.
So I would like to ask Hosen. I see him nodding, and I see him a little bit interacting with this question and with what Marcus is saying. Would you like to also share your thoughts on this notion on the competitivity?
If we are competitive at low TRL level, yes. At higher TRL level, definitely no. And that is something where we are facing. It's not only 1 or 2 years. We are facing from a while our research project to tackle higher TRL levels. If we look now to, I'm quite involved when I was in the even academia until now in different programs when it comes to research. All our research projects, unfortunately, are now still focused when it comes to the battery on low TRL level. And we are not tackling the real challenges which we have should to tackle. It's between 6 and 9. That's where the nightmares of the battery industries are. It's not TRL 5. It's not TRL even 6. So we have excellent universities, research centers, which are able to do that, and they have good results and the demonstration. But the next steps, that is where we have failed, and that's where also a lot of European batteries manufacturers failed as well, and without naming them. And there's still some which fail even in the next weeks and months and years. So we have to be realistic in our approach. Our roadmap has to change. Our roadmap, we should not say industrialization or scaling up is going just to be limited to innovation funds. Innovation fund is just one instrument, but we should have to create much more instruments to tackle this scalability. Why? Because TRL5 dealing with grams and half kilogram, it's fine. And I think we have all our universities can do that. But when it comes to 100 kilograms and tons, you see the real nightmares in the industry. And so there's where you get heart attacks, and that is something where we have to be much more pragmatic from approach. And to be honest, I still never have seen an European cell project, research project, which is dealing TRL 7 and 8. Unfortunately, I never saw that. And I hope I will be wrong, but I still never saw that the last 20 years. And that is what we are needing to develop that, to scale that up, and to have the infrastructure for that. Still, a lot of our companies, when it comes to scaling up, they go to Japan, Korea, and China. That's a hard reality. So we need to set up this ecosystem here in Europe in order to support, so that we will not start having, let's say, will not be having the same mistakes as we made with another gigafactories.
Okay, thanks, Hosen. Of course, very clear views on what's going on. I would also like to complement this question from the point of view of Hoang, from his understanding of what is this European roadmap competitive. Is it enough? Is not enough? How we are dealing with this?
So yeah, I totally agree with my colleagues and what they said before. As an industrial, we buy cells. We would like to buy European cells, of course, uh, but the problem is they're much more expensive, and also the clients, the final clients, so our clients want a competitive battery. So of course, the cell represents 60 to 80% of the price of the battery pack, and the big problem is we're not playing in the same field. The price of the energy for the production in Europe is much higher. The workforce is higher than Asia. And when we see and we study the Net Zero Industry Act, the Clean Industrial Act, and also the battery regulation, there are some environmental entry barriers that they are putting that is not enough from my point of view to have the same level playing field, let's say. It's totally different. All the if we put, for example, the recycled content that is required in the battery in the years to come, the Asians can do the same very easily. The battery passport also, all the traceability and all the barriers that that Europe is trying to put for the industry to be competitive can be overpassed by the other actors very easily for today. So yes, I would like to say that we are competitive, but for the moment we are not. And like my colleagues said, it's also about technologies. For example, we have no LFP producer today, which is the technologies that would spread and represent the majority of the market tomorrow.
Thank you. I think Noshin wants to comment something, maybe.
Yeah, actually, I heard often that we in Europe, we are more expensive, labor cost is more expensive, and this and so on. I think the cost is not the main target. That's to be very clear. And we are dealing with in an industry, automotive, where the sustainability is a key parameter. Battery cell industry, even battery pack industry, is fully automated industry. So that means the labor cost from the overall picture is not very huge and doesn't have huge impact. That's to be very clear. And we should to compare each time apples with apples and not apples with pears, which means we have to calculate the entire cost cycle and not just the price which you get on a quotation. So from that perspective, I don't agree with my colleague Hoang actually that we will be expensive dramatically, but we have also to understand we are dealing with China, which is over-subsidized battery industry. It's an industry which is extremely over-subsidized, and we need countermeasures, yes, to make a balance between what we are providing, what they are getting. That's a hard reality that we have to face with that. But again, still the major cost in a battery industry, cell battery industry, is still firstly the energy, logistics, and on the third place, the human resources. So, and not vice versa. And that is things which have to be optimized in a proper way. But again, the pricing that we see from Asia, in particular from China, that are virtual pricing. If you take out the subsidies that they are getting over there, then you will really face the real pricing on the market, and which are much higher than actually what we are getting right now, as has been indicated by Marcos, Alibaba, etc., etc. So we have to see the reality as such as well. There is China is a reality, but behind China is also another reality in the industry. So if we are expensive in Europe, I would say yes, but in reality, if you deep it very well, it's not the case.
Thank you, Noshin. We have different opinions. That's fantastic for this panel. Marcus, you want to also add something from your side?
Yeah, I mean, it's really interesting what Notion says, yeah, about the subsidies in China. Yeah? But before you introduce these technology readiness levels, these TRLs, yeah, and you mentioned, hey, it becomes really painful if you go to 8, 9, yeah, where it's serious, but it's really costly also to develop this. I mean, it's then about scaling, building factories, building up supply chains, yeah, making all these quality checks that you need to have the right cells. And if you say public funded projects should go more in this, yeah, but there we're talking about hundreds of millions or billions of. So, I mean, if we ask there for subsidies, then it's not a public funded project about 10, 20, 30 million euros. You got about hundreds. Yeah? And for me, that feels a bit like the similar, like subsidies in a really large scale. Yeah. But yeah, in China, it obviously happens. And now they have the business to fund their further development, yeah, where we're just spectators at the moment. Yeah.
Thank you, Marcus. Time is running, so we are not at the end of this webinar, this workshop. There is a comment about going up in TRL 7, 8, which is mentioned by a colleague from RTD, that is no longer grant-based public support. It should be tackled by equities and other related instruments, it says there. But I think it has been very nice also to highlight what is the issues that we are seeing, and each one from each point of view. Industry, we have academia as well. And now I would like to, let's say, close this panel in which we have been tackling competitiveness, we have been tackling bottlenecks of how European industry can be more attracted to this kind of projects. And now I would like to start with the Q&A. We have already a couple of questions in the chat. I'm going to take the first one from Tas. And what he's saying is that one thing that comes to his mind is the challenge of shipping the cells themselves, whether they are bought somewhere or a prototype within a project itself. So how this shipping across Europe is very challenging. Is this something that you would like to address somehow? What are your thoughts here on the shipping, Marcus? For example, yourself.
Yeah.
What is coming to your mind?
So I mean, the cell that we purchased at the end, I mean, these are no prototype cells. These are series cells with some UN testing, so they come packed and labeled as a battery, and there's some process for this. But I agree in my previous, if you have a prototype cell, it's always dangerous goods shipping, and you need, yeah, it's super costly. Maybe you need to even to rent an own van with a experienced guy. So this is costly, but I mean, obviously there are solutions, yeah. So it was never a no-go, but it's more costly than sending something non-chemistry, yeah.
Mm-hmm. And related to this shipping, Sazzad, what do you think about this challenge of shipping? And at the end, in the NEMO project, how did you acquire cells? How did you manage?
So in NEMO and also in other projects as well, as I'm more working on the mid-tier level and looking more for the commercial cells, usually they have this 38.3 even certification for transport. So we have not faced any any, let's say, major problem, even from shipping from Europe, within Europe and from outside to Europe. So that's went really smooth. So I cannot comment on the prototype level that what are the challenges.
Thank you, Sazzad. I would like to continue with Hoang. Where should Europe focus to have a resilient battery value chain from your point of view? That you were tackling this very much on your presentation.
I'm sorry, what's the question?
The question is, where should Europe focus to have a resilient battery value chain from your point of view?
Oh, for me, the focus. I would say in all the all the whole value chain. As I showed, the production of cells is linked to the upstream and the downstream. For me, I would say that there are some strategic components like the CAM and PCAM that represent a high value in a battery pack also, and in which Europe is still ahead a little bit and also competitive. And also on the other side, the recycling part that is for the moment not totally mature, but that would address a very good need. So for the moment, I think that for those two elements, from my point of view, we can be still on the race.
Thank you for giving this overview of, as always, including all the needed steps in the value chain. Marcus, cell selection within next BMS.
Yeah.
What can you say about that? How does this the cell selection influence the progress and the scope of the project itself in retrospective? What can you say about that?
So there are two. Let me make two examples. Yeah. So I mentioned about the fast charge capability. The cell that we got can do 1C. Of course, fast charge capability is not just the cell; it's also thermal management and stuff around. So we will never meet the targeting, but also, I mean, 1C is pretty slow to today's standards. So this is where it kind of limits. We can demonstrate how we can make it faster, but just make it faster on the level that the cell really admits to. Yeah, and this will not be very impressive if you compare it to a state-of-the-art cell of today. Yeah, so we can make it faster, but then we need to check again, can we transfer that what we found on this cell to a more modern cell? That's one aspect. And also the electrical impedance spectroscopy, I also learned, I'm not an expert in this. I also learned that a lot depends on the geometry of the cell. So if it's a very symmetric cell, you might get much more meaningful results and can do much more than maybe if it's this kind of smaller cell with a jelly roll inside and whatever geometric things inside. Yeah. So this is where we have to work with what we have and kind of say, okay, let's look for a more symmetric, or let's look for a faster charging cell, which has a better chemistry. So this is where it's a compromise. Yeah. So we not saying we cannot do this, but maybe we cannot reach what we originally thought we could reach. So it's a compromise at the end.
Okay, Marcus, thank you very much. And my next question goes to Noshin. Within the Avesta roadmap, can you tell us a little bit which are the thoughts there for battery manufacturing in Europe?
So first of all, we as a company are focused on two technologies, solid states and and LFP technology. That's to be very clear. LFP from stationary point of view and solid state for automotive. Now, this is really a good question, and it's also much more related to the question that you also asked to colleague Hoang. But we are a little facing, I believe, and we need right now, as urgent as possible, the required tools and instrumentations at higher levels, at political levels, where those regulations should become much more sharper. I will give a very simple example. If we think that we have to protect our industry, the first is we have to do that not by increasing import taxes left and right. I'm not a believer of that, but I'm much more a believer in the fact of the proper regulations. European content for the battery cell is still not implemented properly. The day that you start implementing, that should be the European content percentage. Otherwise, the cells will not be able to be sold or to be imported in Europe. We are going to create the entire value chain in Europe. So battery directive at a good direction in that regard, but from my point of view, is going too slow. So we need that. The recycling content, it's very good, but still also there are holes in the entire regulation there, where still LFP is not very clear where it should be placed in the entire concept. But again, still the hope is there to catch up this industry. But again, we need support from the government and the beliefs. And an investor, I saw some comments from RTD, investor will invest in TRL 8 and 9, definitely. But an investor will not invest in TRL 6 and 7. Sorry, it's too risky for them. We have to come with some kind of a balance in that regard in order to make it. And giving grant or funding project at TRL 6 and 7 should also not be at 100% funding. It can be even at 40% or 30%, whatever, that some kind of risk are well covered in that regard. And that is such mechanism more and more that we are needing at European level. So I see regulations is still not sharp enough. In China, it's much more sharper. And secondly, we need support, and the coming years more and more. And I think the colleagues of Volkswagen, PowerCo, Vercor, as they say, they indicated as well, if the support will not come, we are going to face nightmares the coming years. And I think they are right. And that's the hard reality of this industry. And China also did not happen the battery industry in 1 or 2 days. And the government invested quite a lot in a long-term vision, and we have also to be consistent in our roadmap, unfortunately, and most of our roadmaps is not up to date to the new reality that we are facing. So, yeah, sorry, sometimes for my provocative feedbacks in that regard, but we want to share at least the pain point of the industry.
Thank you, Nosin.
And we are part of them.
It's only now 2 minutes to end up our workshop. We went to your different presentations. We went to the panel discussion. We had here some very interesting Q&A. Thank you for the highlights. And I would like to have the last question, but I will not give you the word. I would like you to use your digital hand. And the question is, do you face similar problems in other projects, not the ones that you are, let's say, representing today, but on other projects that we are working on batteries on your side? If yes, please place your hand on top. I see Sazzad already saying yes. Yes, I see many hands. I see Noshin, I see Marcus. Yes, so this is something that is happening. So thank you very much for highlighting these challenges, these bottlenecks. I think we already gave a very nice overview of the status today for the problems that we are having on battery manufacturing and on battery BMS, for example. And I would like, of course, before closing the webinar, thank you very much to the speakers. Thanks a lot for your time, your valuable time, and to being present today on presentations and the panel and the Q&A. Thank you very much for your different thoughts, and I wish you a very nice rest of the day. Thank you very much.
Thank you very much.
Thank you, everyone.
Bye-bye.
Thank
Bye.
you. Have a nice day.
Bye.
Bye bye.